I started learning PHP in 1999. That was PHP version 3. And it's amazing to see just how much PHP has changed over time. We have namespaces, we have interfaces, we have generics.
Wait.
What?
Wait. But PHP doesn't have generics.
What?
PHP doesn't have generics.
Yeah, check the documentation.
Oh, what the? Yes, PHP does not have built-in generic support. It was proposed at one point in time, but it never made it into the language. There are some people that say that it can't be added to the language, and I hope that they are wrong because generics are a wonderful feature. So if we can't use generics in PHP, that means that our tooling has to provide that functionality. And that's where the problem really lies, because our tooling has to support it. And there is no standard. But thankfully, our tooling does, for the most part, use the same approaches for supporting generics. Now, if you don't know what generics are, don't worry, because we're going to cover that. So let's say that we have a route called numbers, and we want to display the sum of some numbers, but our numbers are going to be stored inside of a collection. I have a collection class, and I guess we ought to look at that class. It's really nothing special. In fact, it's very limited, but it has a private array of the items that it's going to keep track of. There's a method called add so that we can add items to the collection. And then at some point in time, we want to work with all of those items. So the all method just simply returns the items, and that's it. So to use this collection, we are going to add some numbers. So we'll add 1, then let's add 2, 3, and 4. Then we are going to sum those numbers up and output them to our view, which is the welcome view, but I've modified it so that we can provide some content. And we'll just say that the sum is. Then we will take the array sum of our numbers, but we want to call the all method so that we can get to that array of numbers. So in the browser, we see that the sum is 10, but let's throw a wrench into the works. Let's add a string. Doesn't matter what that string is, but it's definitely not a number. And of course, whenever we attempt to run this, we get an exception. Addition is not supported on type string. And this is really the crux of the matter. PHP is a very lenient language, and the tooling that we have is also very lenient because it's based upon, or at least it uses PHP. So even though we got an exception here in the browser that we cannot perform addition on a string, the only reason we get that is because we tried to add numbers and a string together. Ideally, we would be prevented from adding a string to this collection at all. And, I get it. It's very simple. Don't add the string and everything would be fine. But we can't always be guaranteed that we are going to have a collection that contains only numbers. So we need to protect ourselves from being able to supply a string, or really anything that is not a number, to this collection. Well, one of the more obvious things to do is to just create a new class, one that is a collection specifically for numbers. So let's call this number collection, and let's just take the code that we have from collection and we'll paste that in, because really the only thing we need to do is add a type hint for the add method, because we want to work with only ints or floats, numbers, so that now we can use that number collection. And when we attempt to add anything that is not a number, our tooling should tell us, hey, there's something wrong. And it does. We see this squiggly line underneath. It says invalid scalar argument. Argument 1 of add expects a float or int, but Jeremy provided. Now, this isn't going to prevent our code from executing because PHP just isn't that way. But at least as we are developing our application, our tooling is very clear that there's something wrong here. We need to fix it. And yes, this works, but it's not a feasible solution. Because let's say that we need to work with other types of values inside of collections. We would have a string collection or a user collection or a whatever collection. Ultimately, we end up with a ton of different collection classes, and that's not feasible. But that's also where generics come into play, so that we can write a single class and use it for a variety of different types of values or objects, because that is exactly what generics do. They allow us to write generic code. So since PHP does not have built-in generic supports, we have to rely upon our tools. In our tools, expect a template directive. This is on the class. And this is where we get to say, hey, we have a collection that is going to work with a particular type. So this template is the type that we are going to be working with, but this is generic. This is just a placeholder. So I'm using the term or the word type here, but really what you would see in most code is simply T, which is short for type. So anytime that you see T inside of code, chances are it is a generic type. So you could think I could use anything here. So now we have this template T, meaning that this collection is going to work with values or objects of type T. But we can add other annotations, like for example, our private items property. We can say that this is an array of T. But more importantly, we need to add annotations to the add method. Because if we are working with a collection of type T, then we need to specify that item is of type T. But we can't really use T as a type hint. So this is where this annotation comes into play. We have parameter T item. So our tooling is going to start parsing these doc blocks. It's going to see that, okay, this is a collection of T. The items property is an array of T. The add method accepts an item of T. And then the all method returns an array of T. And that's the terminology that we use. This is a collection of T. So whenever we actually create an object of this class, we could say that this is a collection of int or a collection of string or a collection of user. It's important to remember that T is the placeholder. It's the type that this particular collection is going to work with. So now this collection class is a generic class. We can use it with any type of value or object. So we can go back to our numbers route. We can use our collection, but we also need an annotation here. We need to say that this variable is a collection of int. And when we do so, our tooling now knows that this numbers variable is a collection of T. So we should only be able to add numbers to this collection. And we can see everything is fine until we get to the string. We see that Psalm says that this is an invalid argument. Argument 1 of add expects an int, but Jeremy is provided. So again, this isn't going to prevent us from going to the browser, running it, and seeing it blow up. But as we are writing our code, our tooling is going to point these things out to us so that hopefully we won't get to the point of running it and seeing our code blow up. So we'll comment that out and everything is going to be fine. Now, this means that we can take that same collection class and we can use it with strings. Actually, let's call this names. So we're going to make a few changes here. We're not going to call it numbers. We're going to call it names. And we're going to add some names to this collection. So we will have Jeffrey, then let's add Luke and Jeremy. We don't need a fourth name, but we'll leave that there. But notice how our tooling does not like this. If we hover over, we see that invalid argument message again, and that's because we didn't change our annotation. This is not a collection of int, this is a collection of string. So now our strings are okay, but whenever we attempt to add the number 4, well, that's an issue because that is not a string. So that's perfect. That's what we want. And of course, we need to change what we output here. So we'll say name is, and then let's just grab the first name. So we'll have names, we'll call all, grab the first one, which should be Jeffrey. Then in the browser, we will go to /names and voila. Now, generics and collections go hand in hand. I mean, because we just shown how we can create a single collection class and use that with different types of values. But we can use generics in a variety of other situations. Like, for example, let's add another route. We'll call it /guitars. And I have a guitar factory. Now, this is not an eloquent factory. This is just, well, think of it as a physical factory, a factory that makes guitars. But it's not just any factory. It is an electric guitar factory. And whenever we create a factory, we need to specify the type of guitar that we want to create. So I have a class called a flying V, and we need the name of that class. So now this is a factory that only creates flying V guitars, so that we can create a new guitar by calling the make method on the factory, so that then we can return our welcome view and we can supply the content of the name of the guitar. Our guitar has a method called getName, and that is going to get the name of the guitar. So in the browser, let's go to /guitars, and we see Gibson Flying V. And that is perfect, except that I have another class called Expensive Violin. And we can pass that class's name to the electric guitar factory. And in the browser, we can refresh and we see Expensive Violin. Now that doesn't make a whole lot of sense because we have a guitar factory making flying Vs. It should not be making expensive guitars. And type hints aren't going to help us in this case because what we are passing to the electric guitar factory constructor is the name of the class, not an instance of that class itself. But generics can help us out here. But let's first of all look at this code. So I have some instruments. These instruments start off with interfaces. We have an iGuitar interface and an iViolin interface. Then we have some concrete classes. We have the expensive violin, which implements the iViolin interface. Then we have the flying V guitar, which implements the iGuitar interface. That's all well and good, but then let's take a look at our factories. So we have an iGuitar factory, and then we have the electric guitar factory that implements the iGuitar factory. Now, let's back up a second. I'm using interfaces here. You don't have to use interfaces to use generics, but I'm using interfaces so that, well, we can see some of the features, especially for this type of usage with generics. Because essentially what we want to do is ensure that the electric guitar factory can only create guitars and not violins. So we need to start at iGuitar factory. And we are going to make this generic by using the template directive here of T. So just like what we used in the collection, this T is a placeholder for whatever type of object or value that we want to use with the iGuitar factory. But here's the difference. We can be a little more specific here. We can say that our T is of iGuitar. This means that anything that implements this iGuitar factory interface is going to have to work with classes or objects that implement the iGuitar interface. Now we also need to add an annotation for the make method. It is going to return an object of type T, which as we know now has to implement the iGuitar interface. So this is where part of the magic is going to happen, because inside of Electric Guitar Factory, we are going to specify that this is generic. We have the template T, but we also need to say of iGuitar. But we also want to say that this implements iGuitar factory of T. And this is the second part of the magic, because now we are saying that our electric guitar factory is generic. It's working with objects of iGuitar, and it implements iGuitar factory of T, which of course we know T is an iGuitar, but that's still not enough because the string that we pass to the constructor can be anything. So we need to add an annotation here that says this is the class string of T. So this is the third part of the magic, because now we are essentially restricting that this string that we pass to the constructor has to be the class name of a class that is T, which implements iGuitar. So if we go back to our routes, we see that there's an issue here because Expensive Violin does not implement the iGuitar interface. We can see that right here. Argument 1 of the constructor expects a class string of iGuitar, but Expensive Violin was provided. So if we change this to Flying V Guitar, the squiggly line underneath that goes away, indicating that our tooling thinks that everything is okay with this code, and it is. So once again, in the browser, we will see Gibson Flying V. Now, I should stress again that this is for tooling only. If I change this back to Expensive Violin, the tooling is going to tell me that this is not correct, but in the browser, it's still going to execute just fine. So this isn't going to prevent your code from executing. It's just going to warn you that something is wrong as you are developing your application. Now, I have another class. It's an abstract class called Guitar Factory, which implements iGuitar Factory. So I want to include this so that Guitar Factory will implement iGuitar Factory, and then Electric Guitar Factory will extend the Guitar Factory. So let's take our templates here and let's paste that inside of Guitar Factory because we're going to need that here. So our template T of iGuitar, our template implements iGuitar Factory of T. So we're okay here. We don't need to use any annotations because that's going to flow through from our iGuitar Factory. However, we need to make some changes to our electric guitar factory. We want to extend the guitar factory, but we also need to change our template implements because we aren't implementing an interface. We are extending a class. So we need to change this to template extends guitar factory of T. And you can notice it doesn't like that to begin with, but then it goes away. So when you extend a class, you use template extends. When you implement an interface, you use template implements. But of course, whenever we look at our code inside of our route, we aren't notified of any issues, meaning that everything is A-OK. Now, I fully understand that this can be very confusing. I've been using generics for many years, not in PHP, but in other languages. So I came into this knowing what generics are, how they work, and what to expect for the most part. So give this time for your head to wrap around not just the idea of generics, if you're new to generics, but also to this syntax. I mean, ideally, yes, PHP would have built-in support, but it doesn't. So we have to make do with the tools and capabilities that we have at our disposal. So with saying that, I thought it might be helpful to show you what generics could look like if PHP supported it out of the box. I'm not going to worry about the interfaces or anything like that, but this is going to be the electric guitar factory of T, where T is an iGuitar. And then we would have public function make, and all we would really need to do here is say that it returns something of T so that we could return there. And that's kind of what it would look like. It's very easy to follow, at least I think in this case, and it reads very well. Electric guitar factory of T, where T is an iGuitar. And the make method returns an object of T, which is an iGuitar. And then to use this, it would look something like this, to where we would create our factory by newing up the electric guitar factory, and then we would specify the type of guitar here. So that would be Flying V Guitar. We wouldn't have to pass anything to the constructor because the factory would already know what kind of guitar that we were working with. So then we could just call factory make. So that's what it would look like. And hopefully that makes it a little bit easier to understand how all of this is working. All right, so the last thing that I want to look at is using two templates. Because so far we have been working with one. What about a class that could work with two? So this is going to be another collection, and this is going to be called a hash set. And we're going to have two templates because a hash set is, well, it's a special kind of collection. We would have a key, which in PHP can only be an integer or a string. And then we would have the value associated with that key. And I can hear you, yeah, we already have that built in. Yeah, we do. But we're going to have another example here. So we have our first template, which is going to be our key. So I'm just going to call that T key. The identifier here really doesn't matter, but typically we use T for whatever type of value or object we're working with, and T key, in this case, to specify that it's a key. We could call it foo for all that we care, but let's at least follow some kind of convention here. So we'll have T key, but this is important because keys can only be ints or strings. So we need to say that the T key is of array key. Then we have the second template, which is T, which is going to be our value. So our hash set is going to have a private array called values, but we need to have our annotation here. This is going to be an array where the key is whatever is specified as T key. The value is T. Then we will have a public function called set where we will have our key and the value. And the code for this is going to simply use our values where we have the key equal to that value. But once again, we need our annotations. Our key is of type T key. Our value is of type T. And then we have the get method where we pass in the key and we return the value at that given key. But once again, we need our annotation so that our key is of type T key. Return is type T. So let's use this. Let's go back to our routes. Let's define a new route. We'll just call it /hash. And then inside of this route, let's create our new hash set collection. And let's go ahead and define our annotation here. So this is a hash set. Let's say that the key is going to be a string and the value is going to be a string. So now we can call the set method. We can pass in a string for the key. Let's have the name of a month, January. Then we will have the abbreviated form. So we'll have January, February, and then we will have March. Did I spell February right? I think so. But then let's try to add something that doesn't match. So our key is going to be an integer of 1. The value will be April. We can see our tooling does not like that. Hovering over says that there's an invalid argument. It expects a string, but one provided. Oh, well, okay, we'll fix that, I guess. So we'll have April, and then we will have 4 for the value. Once again, we are notified that there's an issue. Hovering over shows that argument 2 expects a string, but the number 4 was provided. So we can fix that. And now our tooling is happy. PHP does not have built-in generic support, so we have to rely upon tooling. And I've said that quite a bit throughout this episode. And I have found that different tools offer different levels of support. Like, for example, PHP Storm has some built-in capability for working with generics, but it wasn't complete. In fact, it downright failed on some very important things. Like, for example, in our guitar example, if I used expensive violin, it would never notify me that there was an issue here. And that's kind of important. That's one of the reasons why we use generics to begin with. I had a similar experience with the PHP Stand plugin, but Psalm really was the only one that I had any level of success getting the results that I expected. So different static analysis tools are going to provide different results. Now, with saying that, my experience with Psalm was, well, it was very slow. Now, I am running this on a virtual machine. It has plenty of resources. It's running on an SSD. So there shouldn't be that big of an issue, but there could be. And two, I'm also running it on Windows, and I did read some issues where it runs slower on Windows. I don't know. I do know that I had to wait 5 to 10 seconds for anything to show up as to whether or not something was okay or not. Now, I could have misconfigured any one of these tools. That is a possibility, but I did spend a lot of time trying to make everything work, and really Psalm was the only one that provided results, even though it was slow. And there are other aspects to generics, covariance, contravariance. Those are things that do have some support, but once again, that level of support is going to vary based upon whatever tool that you use. And besides, these tools probably only partially simulate those types of features. So all it does is just show how badly we really need generics in PHP. Hopefully one day we'll get there. I started learning
Stop! Stop getting me in a giggly mood!
Hey.
Oh, what the?
Isn't that cool?